Do you know that the n-queen problem is the most popular and the most commonly asked backtracking problem that are asked during the technical interview? Hi, my name is Anindo and today over here we will be solving the n-queen problem in the much easiest and the simplest way so that you do not need to go to any other video to understand the problem. Because over here today we will be solving this problem with the help of the animation and also we will be solving each and every line of the code so that it will be damn easy for you to solve this problem during your technical interview. So without wasting much time, let's understand that how we will solve this problem in the most simplest and the easiest way. But before solving this problem, I would like to request you that please do watch till the end of this video because backtracking is an interesting and a critical topic of the data structure and algorithm. So if you do not understand each and every component and each and every procedure of how to solve a backtracking algorithm, it will be very difficult to understand this type of solution. So I would highly recommend you to go through this complete video, and at the end, if you like this video, please do like and share with your friends. And if you are new to my channel, do not forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So without wasting much time, let's start with this video of understanding that how we can solve this n-queen backtracking algorithm in the most simplest and the easiest way. So let's get started. So before solving this problem, let's first understand the problem. So the problem statement means that given a chessboard of size n cross n, which means that total number of rows and the columns of a chess will be n into n. So if you know the game of the chessboard is nothing but a grid structure which have n cross n cells over there. So for example, if the size of the n is equal to 4, then the total number of rows over here will be 4 and the total number of columns will also be 4. And over here we need to solve a tricky problem, that is, we need to place the queen of our chessboard in such a strategical manner and in such a strategical position so that no two queens can attack each other. So let's first understand that what this problem statement means. So if you know that within the chess game we have a queen, and the movement of the queen is it can go in the horizontal way, it can go in the vertical way, and also it can move in the diagonal way in all the four directions. And if there exists any other queen on this line of action or the line of attack, then this queen can easily cut the another queen or it can attack at the another queen. So over here, for example, if we place the first queen over here, then we cannot place any other queen on this row and on this column because this row and this column are the line of attack for this queen. And also we cannot position another queen on the diagonal line that is over here. So the next safe position for the another queen on the second row is either this position or this position, because this two position doesn't comes under the attack of this queen. So we can safely position the next queen either over here or over here. So in this way, over here across the board on each and every row, that is in total n rows, we have to place one queen on each and every row so that no two queens can attack each other. So over here, since the total number of rows is 4, so the total number of queens that we can place is also 4. So over here across this total board, we have to place 4 queens somehow so that the two queens cannot attack each other. So this problem is basically a classic example of the backtracking problem. So first understand that why it comes under the backtracking problem. Because over here you can see, to find a particular solution on the first go itself, we cannot tell that this position of the queen is the final and the ultimate position of the queen in this board. So over here, while solving for the other rows over here, it might can happen that this position of the queen is not the actual or the correct strategical position for this queen. So we need to backtrack our algorithm and we have to undo our solution so that we can exactly find the correct position at which the queen will get placed. So initially this solution might seem quite difficult and very difficult to understand. But believe me, over here we will be solving this problem in such a way that it will be very easy for you to understand the entire algorithm over here. So during the interview process, the interviewer can easily ask you to solve the 8 queen problem. So whether the value of n is 8, 4, 2 or whatever, the solution will be same for all the values of the n and is also quite simple to understand. So without wasting much time, let's start with solving this problem and let's first understand that how we shall solve this problem with the help of our visual display board. and over there we will be solving that problem, that is the n-queen problem, keeping the value of n as 4. So before writing the algorithm and writing the complete code to solve this problem, let's first understand the logic and the way how we will be solving the problem over here. So let's first understand this problem with the help of our simple visual display board. So over here I believe you already got the problem statement. So the problem statement is very simple. Over here, given a board of size n cross n, that is 4 over here, we need to place 4 queen over here strategically so that no 2 queen can attack each other. So let's first understand the algorithm, that how we will be solving this problem. So to solve this problem, what we will be doing, we will be starting our solution with the first cell of our board, that is the row 0 and column 0. So this will be the starting index of our solution. So over here on our first cell of the board, we have to first check that whether it is safe to put our first queen over here. So over here for the first time, since the entire board is empty, so it is quite safe to place our first queen over here. Now the problem statement tells that we need to place n queen on n row. So obviously there is no need to place any other queen on this entire row. So once we are done in placing a queen successfully, what we will do, the next step of our algorithm say that we will go to the next row of our board. So on our next step, we will go to the next row, that is row number 1 and column number 0. And over here we will again check that whether this cell is perfect for another queen to be placed or not. So over here if you try to check that whether it is safe or not, you can see that this position is not safe for another queen, because already there exists a queen at the top on the same column which can easily attack the next queen. So over here we cannot place the next queen over here. So what we'll do, since we cannot place the next queen over here, we will move to the next column of the same row, and that is row 1 column 1. And over here we will again check that whether this position is safe for the next queen or not. So over here you can see there is already a placed queen diagonally at the top, so this position is not safe for the next queen. So what we'll do, we'll again move forward to our next step, and that is the next column over here. And over here we will again check our condition that whether it is safe for our next queen or not. So over here you can see all the 8 position means all the attacking position for this queen is safe, because there is no other queen those are placed on this line of attack. So we can safely position our next queen over here. So I hope you guys have got the idea that how we are checking on each and every cell that whether it is safe for the queen or not. And if it is safe, we are placing the queen over here, otherwise we are moving one column at a time. And if we are successful in placing a particular queen in a particular row, what we are doing, we are moving to our next row to find the next secure position for the queen. So let's move forward with this algorithm and let's iterate one step over here so that the algorithm becomes much more easy for you to visualize and you understand each and every steps over here. So let's move forward and let's see what we will be doing on our next step. So over here, since we have successfully placed our queen on our second row, we will move to our next row, and that is the third row. And over here the row number is 2 and the column is 0. So over here again we will check that whether this position is safe or not. So here you can see we already have a queen at the top, so obviously we cannot place the next queen over here. So this position is not safe. So what we'll do, we will move to our next position, and that is the second column over here. And over here again we will check that whether it is safe or not. So here you can see this position is not safe, since over here we have an attacking queen over here. So this position is not safe, so again we will move forward. So here also in this position this is not safe, since at the top only we have an attacking queen over here. So we'll again move forward, and similarly over here we can also not place another queen, since this queen is already placed in this attacking position. So what we'll do, we will again move forward, and over here you can see we are getting out of range of our boundary. That is, we are getting out of range of our chessboard, which means that it is not possible to place a queen in this entire row over here. And thus over here we can conclude that the queen that we have placed before this row, which means this queen, is not strategically the correct position for this queen over here. So what we will do, we have to backtrack our solution. Means whatever the solution which we have given over here was wrong. So we need to undo, or we need to backtrack our solution And that is why this problem, that is the n-queen problem, comes under the backtracking algorithm. And in this way, we have to backtrack our solution and we have to repeatedly do this step so that we can place each and every queen in the most strategical and the safest position within this board so that we can safely position all the 4 queens in our board. So let's now see how we will solve this problem over here. So what we'll do, we will again go back to our previous solution, that is this one, and since over here we have identified that this queen has not been placed in the most safest position to solve our problem, so what we'll do, we will undo our solution and we will again try to find out the next possible solution for this queen on the second row. So what we'll do, for this second row, we'll again move forward, that is we will move forward to the next column, that is the last column over here. And again we will check that whether this position is safe to provide a queen or not. And since over here there is no attacking queen on any of the side over here, we can easily conclude that yes, this is another safe position for the queen, and yes, we can place the queen over here. So what we'll do, we will place another queen over here and we will move forward with our next row over here. And in this way we will keep on iterating and we will keep on checking each and every cell and we will place our solution. And at any time if we find that we are not able to place the queen in a safest position, we need to backtrack our solution. So let's now see how we will place the third queen over here. So again we will check that whether this position is safe or not. So this is not. So we will move forward over here and we will check that whether it is safe or not. And over here you can see that on all the 8 side over here, there are no queen over here to attack this particular queen. So this is actually a safe position for us to place a queen. So we will place a queen over here. So till now we have found 3 safest position for the queen on this board. Now we have to find the last and the final queen position in this board on the last row. Let's see that whether we can place that queen over there or not. So since we already got the solution on this row, we'll move forward with our next row, and that is the last row over here. And again we will check that whether this is the safest or not. So here you can see this is not the safest. So we'll again move forward. So we'll go to the next column. Here also you can see this is not safe. We'll again move forward. Here also you can see this is not the safe position since we have an attacking queen over here. So again we will move forward. Here also on the next row, that is the last column, it is also not safe to place the queen. So what we'll do, we'll again move forward and you can see we are out of range of our boundary of the chessboard, which means that we have again make a mistake of finding our previous solution, which is nothing but this one. So what we need to do, we again need to backtrack our solution and we have to undo our solution. So what we'll do, we will delete this queen from here and we need to find the next possible solution for this queen on this particular row. So what we'll do, we'll again start from here, that is the next column over here, and we will check whether this cell is safe or not. So here you can see this is not a safe position. Again we will move forward, this is also not a safe position, and again you can see we are out of range of our boundary, and over here you can see we have not found a proper place for this queen on this entire row, which means that we have made a mistake on our previous solution, which is nothing but this one. Oh my god, so you can see how many backtracking we are doing over here. So what we'll do, again we will delete this queen from here and we will try to place the queen on our next position, and that is the next column. And over here you can see we are out of our chessboard, which means that this row is also not the safest position for our queen to be placed. So what we need to do, we need to again backtrack our solution, which means that the first solution that we have placed over here was wrong. So you can easily understand that though I knew that the first position was wrong for me, I need to explain the whole process so that you guys can understand each and every steps that how we are doing the backtracking over here. So don't worry about me, I am very happy to explain you guys that how you should solve this n-queen problem in the most optimized and the easiest way. But just for my effort of doing all this backtracking, I just want you guys to like this video and please do share this video. And if you're new to my channel, please do subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's now again move back to our problem and let's see what is the next position where we can place our queen safely. So what we'll do, since we already got to know that this is not the position or this is not the correct position for the queen to be placed, we will delete this queen position from here and we will move forward over here. And since over here you can see that this cell is not being attacked by any of the adjacent queen over here, so we can easily place a queen over here. So what we'll do, we will place a queen over here and we will move forward. So, and since you already know the algorithm that if we have placed successfully a particular queen, we have to move forward to our next row. So we'll move to the next row and we will keep on checking that whether that position is safe or not. So here this position is not safe, so we'll move forward. And here you can see on the last cell over here, this is the safe position for a queen. So we'll place the queen over here and we will move forward to our next row, and that is the third row over here. And over here you can see this first position is actually a safe position for a queen to be placed on this row. So what we'll do, we'll place a queen over here and we will move to the next row and we will try to find out the correct position for the last queen over here. And finally at this step on the row 3 column 2 we have found the last position where we can place our last queen, and that is the fourth queen in the board, and we have found the solution to our problem. So over here you have seen that how incrementally and strategically with the help of the backtracking algorithm we have strategically found out the correct position of the queen which can be placed at a particular position on the cell. So there can be plenty more solution by which we can place the queen on this board. So if you can see, this is another solution for this 4 queen problem. So this is another way you can place the queen so that 2 queen doesn't attack each other. So I believe you guys have thoroughly understand each and every step by which we have tried to solve this problem. Now I will again start the video from the front and I will try to iterate each and every step without any explanation so that it will be easy for you to visualize the complete overall structure of the solution for you guys. And after that we will be implementing the entire code using the Java language. But do not worry, though the algorithm looks quite difficult to implement, but it is actually quite simple, and since I will be explaining, I can guarantee you that will also be quite a simple thing for you guys. So let's now quickly see the dry run of this algorithm one more time. So hopefully you have guys thoroughly understand the concept by which we are solving this problem. So without wasting much time, let's start with the solution of solving the n-queen problem using the Java code. So let's over here start with the implementation of this algorithm using the Java code. So over here you can see to implement this algorithm I have created a normal class called as n-queen, and over here I have a method called as main, and within this method main I have a 2D matrix called as chessboard, which consists of the size of n as a variable over here at the top. So over here you can see I have defined the size of this matrix as 4. So you can make it 8, 16, whatever you want. And one more function you can see over here I have defined is the print board, which do a simple function of printing operation of this entire matrix. So over here it takes the matrix as our parameter, and based on this matrix value it just prints the rows and columns over here. And over here within this main method I am defining all the cells of the matrix with a hyphen symbol so that we can identify this as an empty cell. So let me first print this chessboard and let's start with the algorithm of implementing the n-queen problem using the backtracking algorithm. So let's print it over here. So over here you can see we have an empty matrix of size n cross n which is equal to 4, and each cell of this matrix is defined with a hyphen over here. So now since we are done with the basic setup of the n-queen problem, let's start with building the algorithm over here. So for that I will be creating a utility function over here. So let's name this function as n-queen solution. And over here from the main method I will be calling this function, that is n-queen solution. And within the parameter I will be passing the chessboard as one of the parameter. And over here in our parameter, we will be passing the first row from where we will be starting our iteration. So as you know, in our algorithm, we have started our iteration from row 0, and that is why over here also we will be passing 0 as our parameter. So I hope this is clear to you. So what we are doing, we have created a function called as nquint solution, and over here within the parameter, we are passing two parameters. One is the chessboard and another is the first row of our chessboard, that is 0. Now within this npin solution method, let's define and write our function. So as you have already understood from our algorithm that what we will be doing on a particular row, we will be iterating forward on each and every row over here. And on each and every cell, we will be first checking that whether it is safe to place a queen or not. So over here what we will do, we will write a for loop to iterate over each and every column on a particular row. And over here, for each and every cell, we have to check that whether it is safe to place a queen or not. And for that, we will be creating a function called as isSafe. And within this isSafe function, we will be passing each and every cell of our chessboard. So let's pass each and every coordinate of our chessboard over here as the parameter. And let's define the isSafe functionality at the top. So over here you can see that over here I have defined a function called as isSafe to check that whether a queen can be placed on a particular cell or not. Now before implementing this isSafe function, let's define the logic over here, because this is the actual logic of backtracking. And if you see, this logic is quite simple and easy to understand. Let's understand it one by one. So what we are doing, if this isSafe function returns true, which means that it is safe to place a queen in this following row and column. So what we'll do, we will assign the queen over here. And if you are successful in placing a particular queen in a particular position, what we will be doing, we will be moving one step forward, which means that we need to go to the next row of our solution. So what we'll do over here, we will be recursively calling this function, that is nquint solution, and over here we will be passing the chessboard. Along with that, we will be passing the next row of our chessboard. So let's understand what we are doing over here. So if the isSafe method is returning true, which means it is safe to place a queen in this cell, then we are placing the queen within that cell. And if you are successful in placing the queen on that particular cell, we are moving forward. That means we are moving with our solution of placing the next queen, which is actually in the next row. And that is why we are increasing the row number by 1. And if we are unsuccessful in placing the queen at the particular position, that is in this position, which means that after placing the queen, if we find during the iteration that we have placed the queen wrongly, what we have to do, we need to backtrack our solution, which means we need to undo our solution. And for that, to undo our solution, we will be resetting our value from q to hyphen, which was our initial state at the beginning. So I hope this is clear. So if you are placing the queen, you are just asserting the value as q, and if we are unsuccessful in placing the queen in the correct position, then we are resetting the value with hyphen. And believe me, this is the entire algorithm of the backtracking logic, and this is the entire code of how to implement the backtracking over here. So backtracking is very simple to implement if you understand the concept. And one more condition that we have to put over here, we have to put a termination condition, which means that over here you can see we are recursively increasing the row of the column. So we need to put an endpoint to this condition, otherwise it will go into an infinite loop. So let's see what termination condition we will be placing. So over here we will check that if the size of the row, that is the index of the row over here, is equal to the size of the array or the matrix, then we can conclude, yes, we have got all the nquint solution, because over here n is nothing but the size over here. So if we have reached the last row, that is the nth row over here, which means we have got all the solution, and thus we need to print the board over here. Else we will keep on moving forward with our iteration. And that's it. This is the simple code of how we will be implementing the endpoint logic using the backtracking algorithm. Now the only thing that is pending over here is how we will be implementing the isSave functionality over here, which is actually very simple and straightforward check that we will be implementing over here. So let's implement the isSave functionality over here and let's complete this program. So within this save functionality, we have to see that whether it is safe to place the queen on the horizontal line or in the vertical line. And also we have to see that there should not be any attacking queen on the diagonal lines over there. So let's place this fourth condition to check that the queen is safe to be placed on a particular cell. So let's first check that whether it is safe for the queen to be placed in a particular vertical line, which is within a particular column. So if there exists no attacking queen on the vertical line, which means over here in this direction, then we will be returning true, otherwise we will be returning false over here. So the next check we have to do is whether it is safe to place a queen on the horizontal line or not. So this is quite a simple logic. So over here we have checked that whether it is safe to place a queen in the horizontal line or in the vertical line. Now we have to check two more conditions, that is whether it is safe to place a queen on the left hand side diagonal line or in the right hand side diagonal line, because these two also are the attacking position for a particular queen. So let's check these two conditions also over here. So with this condition, we are checking that whether it is safe to place a queen on this direction or not. So this is one of the checkpoint. Another checkpoint we have to do is whether it is safe to place the queen on this diagonal line or not. So let's also put this condition over here. And if there exists any queen on this diagonal element, we will return false, otherwise we will return true. So this is basically the entire program of implementing the n-queen problem. So let's run the entire program over here and let's see the output. And great, over here you can see we got the two output, that is this one, which is the first configuration by which we can place our n-queen, and this is the another condition by which we can place our n-queen solution. So let's format this a bit so that it will be easy for you to understand, and let's run it again. So over here you can see this is the empty board that we have started with the initial stage, and this is the solution 1 and this is the solution 2 that we have achieved by the process of backtracking algorithm. So hopefully you guys have thoroughly understand each and every way by which we have implemented the n-queen problem by using the backtracking algorithm. So if you have any question regarding this, feel free to let me know in the comment section below. I will be happy to guide you over there. And if you have liked this video, do not forget to like and share with your friends. And if you are new to my channel, do not forget to subscribe and hit the bell icon so that you never miss any update from my side and you're always ready for your next interview. So see you on the next video. Thank you.